Hello, everyone. Welcome to the Image & Wire Show. My name is Jake Fishman. I'm the host of the show and the editor of the Image & Wire newsletter. And we have an awesome episode for you all today. We have Sebastian Ricci from Siemens Healthineers on with us today. He is the product portfolio manager on the molecular imaging side of Siemens, which is a big job. And he also has a really cool career background and role right now. And there's a lot to learn. And I can't wait to do all that learn and share it with you. So Sebastian, welcome to the show.
Thank you, Jake. It's great to be here with you.
That's really good to have you with us. So Sebastian, I noticed that you have this career both on the clinical side and on the vendor side, of course, of molecular imaging. And I was hoping maybe you could start us off by sharing about your background, the things that you did before and what that brought you today and what you focus on now.
Sure. So I'm a nuclear medicine technologist by background. I became a technologist many moons ago. I've had experience in hospital settings and outpatient clinics. I became a manager at one of my facilities and spent many years managing the nuclear med department. My responsibilities grew to all of outpatient imaging and IR. And eventually I became the radiology director at the facility, responsible for imaging at the hospital and 2 outpatient centers. And we were building a third when I decided that Siemens was a really good opportunity for me. This opportunity came along to be a product manager for molecular imaging for Siemens. I am currently the SPECT product manager for the North American group. So I'm responsible for all the SPECT and SPECT CT products and their clinical marketing in the United States.
Wow. So those actually both sound like really big jobs. How long were you on the nuclear medicine technology side? Or on the
I was a technologist
side?
for 15 years and in administration for about 10.
Wow. Okay, great. So I'm sure that's probably a lifetime in the nuclear medicine space. I'm sure you've seen a lot.
Yeah, it's been a very interesting career. Seen a lot of patients and a lot of good things along that way.
Right. So I guess fast forwarding today, what are some of the big trends that you're seeing in that space?
So it's very interesting today in molecular imaging and SPECT. What we're seeing is a lot of change, a lot of growth, and a lot of new directions coming along. We're seeing patient populations evolving. We're seeing new therapies and theranostics becoming a big, important part of molecular imaging. It's starting to grow at a rate that is double what it has been in the past. We're also seeing the importance of patient experience continuing to grow, as reimbursement is becoming more and more tied to patient satisfaction. The importance of that patient experience and how the patient interacts with your staff is becoming paramount. We're starting to see a lot of staff shortages and supply shortages. We're seeing a retirement wave in clinical staff, a lot of stressed out technologists through COVID, and seeing a lot of people leave the industry. So we're starting to see a very big shortage in technologists. It's predicted that there'll be over 10,000 standing jobs without anyone to fill them within the next 5 years. And then we're also seeing the rising cost of providing care. It's getting more expensive at the gas pump today for you and for everything else, including medical care. So we're seeing a lot of issues and challenges facing the industry today.
Wow. So on the change in patient population, how is it changing?
So we're seeing patients living longer. We're seeing new therapies being introduced, and the growth of theranostics is becoming paramount in nuclear medicine. You still will see your normal bone scans, HIDA scans, renal scans that can't be replaced with other modalities, but we're starting to see nuclear medicine evolve to its next phase, where we really think theranostics is going to be the trend that's going to take off, where you're pairing a diagnostic and a therapeutic agent with imaging done with PET and therapy done with an agent that you can image through nuclear medicine or SPECT to see how well the therapy is working and quantify what's going on. So you're seeing that personalization of medicine going forward, and you're seeing patients being taken care of in a different way that is much more personal medicine and much more quantifiable.
Let's make sure we talk deeper about Theranostics later. This is super interesting. Based on the kind of the group of challenges and trends that you're seeing right now, I understand that you recently launched, actually we covered it in Image and Wire, a new SPECT CT system a couple of weeks ago. Maybe you can tell us a little bit about that system and how it applies to those trends and challenges that you're seeing.
We launched the Symbia Pro.specta SPECT CT on June 9th, and we are thrilled with the response we've gotten so far. The system, it provides more clarity with new SPECT features, more detail with fast, low-dose CT, more productivity with a single intuitive user interface, and more room with a streamlined design. And all of that is allowing us to say that this system is allowing you to reach your full potential with intelligent SPECT CT imaging today and into the future. So when we talk about that, I'd love to start with some of the features on the SPECT side. New to the system, we have intra-recon motion correction, data-driven motion correction with a solution that is simple for all SPECT studies. It allows it to be integrated into the workflow, and with one click, you're getting automated motion correction in your reconstruction, which is a big deal for the technologists. It means that they don't have to manually click through each frame and look at each frame. The automated workflow allows it to be done and looked at as soon as the reconstruction comes up on your screen. What we're really talking about, again, is making it easier and more reproducible for technologists to technologists. What that does is, as we're dealing with staff shortages and other concerns, we are making the workflow reproducible and easy to follow. We're making it easy for the technologist to use, and we're making it automated, which allows for more reproducibility from one technologist to the other. In practice, Jake, what that really allows you to do is, if you need to go into for a scan today and have it done, and it needs to look beautiful for the radiologist to read, we want to make sure that we give you the best image quality for that radiologist to look at for you. It automates that procedure to a great extent. So the technologist reviews the images after they're automatically produced, and 99.5% of the time can just send them along for the radiologist to read. And what that means is it makes it easy if you have an exam today, and if you're a cancer patient, you usually have repeat exams. So you're coming back at 3 months or 6 months or a year for a follow-up to make sure either your therapy is working or that you're in remission and there's no other concerns. So if I did your scan today, you want to make sure that the scan is processed the same when you come back, either 3, 6 months or a year later. And this automated workflow allows that. So there's reproducibility from technologist to technologist, making the baseline very even for the radiologist and giving them increased confidence that they're looking at the same thing produced the same way during each scan. And we've added a bunch of features along those lines, like we talked about that intra-recon motion correction. We also have respiratory motion correction for cardiac gated studies. We have continuous acquisition for all SPECT studies, including gated studies. Attenuation and scatter correction for all SPECT studies and SPECT CT studies. And that, again, is for all gated studies included. So by doing this, we have added a bunch of new SPECT features on top of our proven Symbia technologies. As far as the workflow is concerned, we've created a new intelligent workflow. The interface is very easy to learn. And what's happened in the past with prior generations of SPECT CT is you had to go into one interface to perform your SPECT portion of your study, a separate interface that looked entirely different to do your CT study. And then you had to process them together in what sometimes was a third interface. Today, now with our new system, it is a smooth single interface that allows you the same workflow through SPECT and SPECT CT and the CT portion. Everything looks the same. We streamline processes by making it a one-click on and off. I know that sounds silly, but in nuclear medicine, Jake, most equipment has a series of buttons you have to press, whether on the computers or on the gantry itself to turn it on and off in a certain order. Now it's just that one button on and off to make life easier for the technologists. Again, we want to make reproducible images. We want to make it easier for the staff. We've reduced the clutter in the control room. There's no PCs, which is a big deal. As a technologist for 16 years, there were always a ton of computers under your desk. I personally accidentally kicked the connection apart on one of them once or twice and had to call service myself because I didn't know which wire went where, right? Today, with our new system, all those computers, all that computing power is housed within the gantry. So you have a really clean, small workspace, which is just 2 monitors, a keyboard, and a CT control box, which is a big deal in nuclear medicine. It makes for a very clutter-free environment, gives your tech space to work, and an easy workflow. On top of that, as far as flexibility in the room, what we've done is produced a system that has increased flexibility in a room size. So you can fit this system in most SPECT rooms from the prior generation, making it easier to move from prior generation SPECT only systems to SPECT CT. The system will fit in roughly rooms that are at least 19 feet long and a certain distance wide. I think it's 12.5 feet wide, roughly. If the room is pretty square and there's not many obstructions, we can make a system fit in that room and allow you to upgrade to SPECT CT without doing a lot of room reconstruction. Construction costs are rising, as we talked about the increased cost of rising care. So trying to minimize that by making a system that will fit in some of your existing rooms was really important to us. We really took all of our customers' input and took our time to really think about how to create this system. One great story I have is my counterpart who works on the PET side. So I do the SPECT side, and my counterpart who works on the PET side, he also comes from a clinical background. They took a lot of input from technologists when they were producing this system. They sat down with techs and talked to them. He has recently joined us at Siemens, even newer to Siemens than I am. He's been here less than 3 months. But one of his experiences in the past was he was invited as a customer out to the factory to give input on this system. So he remembers going to the factory and his notes about some of the things he was concerned with as a technologist that really mattered to him. And when we reviewed those notes, we noticed many of those things were in the system already. So this is what we're talking about, is really moving to a 21st century workflow with input from the technologists and really making a technologist-friendly system that fits budgets today.
That's awesome. And there's so much to dive in there. And a lot of them really just address the points that we talked about earlier. When you talk about early on, when you were talking about basically the automated and reproducible workflow, when say with an older SPECT CT system or just a current one that's not the Symbia Pro.specta, how often are they repeating or scans and without the automation, how much time is a normal scan? Understand that there's some repetition.
So there's a repetition of the scan is based on patient motion. As a technologist, in my experience, probably 1 to 2 out of 10 times I was doing a cardiac scan, I would have to repeat the study just because of the patient motion, or I'd give it a radiologist an image that wasn't of high quality, that wasn't really readable for them. And that's the worst thing we can do for patients, right? You're either giving them poor quality images that aren't going to really get an answer for them, or we're causing them more discomfort by keeping them on the table longer. What this is allowing us to do is really check that motion correction, make sure it's correct, and automatically reproduce it for us in a short time period. So literally today, I could be getting the patient off the table, the computer will automatically process it, and I can check the images before the patient is in a position to get up off the table. So what we're talking about is that productivity factor, making throughput easier, increasing your productivity so that you can get more patients done in a day in your department, which is good for your bottom line. It's good for your technologists. It makes life easier for everybody. And it helps improve the your facility's bottom line. Whether it's an outpatient center or a hospital, you always want to make enough money to make it profitable, right? And in this case, we're helping you do that.
The fact that the Symbia Pro.specta can fit into most existing spectrums, for other SPECT CT systems, could they, or are they just simply too large to fit into most SPECT CT rooms?
Older SPECT systems and SPECT CT systems had a smaller footprint than SPECT CTs do. Just because of the added CT on the back end of the gantry, in many cases, you just needed to be longer. The rooms needed to be longer to allow you to go from the SPECT system through the gantry into the CT board. So with our new system, it allows some flexibility in siting, allows you to make it a little shorter and a fully customizable travel. So in some cases, you can limit the travel so you may not get a full SPECT CT co-scan length, but you'll be able to do it and have a limited co-scan length. So with that limited co-scan length, we can image most patients. They've calculated out to be up to 6'4" approximately, that we can scan them for cardiac studies and still get the full heart in the field of view. So yes, you may have some limitations, but you could still produce a high quality image on most of your population and get newer technology.
Do you have a feel for, across the US, how many SPECT systems are just single function SPECT cameras without the CT? What percentage?
I can give you a percentage, not a total systems. In the United States, it's more there's more SPECT than there is SPECT CT. It's roughly 40% SPECT CT and 60% SPECT only. The rest of the world is flipped even greater than that. So it's more like 70-30 roughly for the rest of the world. They're more SPECT CT than they are SPECT. It has to do with a lot with reimbursement here in the United States and slower adoption, but we're moving towards that. And we've started getting CPT codes in the last couple of years that are specific for SPECT CT. So we're really thrilled with the beginning of that and having multiple codes for different studies, including parathyroid and localization studies. So having additional reimbursement is going to help us get more of these systems out into the field here in the US.
Right. And more rooms to fit into.
And more rooms to fit into, correct.
Got it. So a couple weeks ago, you had the big nuclear molecular imaging show up in Vancouver, I would say around the SNMMI. And
that's it, the Society of Nuclear Medicine and Molecular Imaging. It's a real mouthful.
It is quite a mouthful. And this was the big coming out party for the Symbia Pro.specta. What were the types of conversations you had? What do folks have to ask about it?
So one of the things I already covered with you was the on and off button. I know it sounds trivial, but technologists really came up to us and said, is it truly one on and off button? And we said, yes. They didn't really believe it. That was the big showstopper. And visually, the big difference was that clutter-free workspace that we talked about. And then we went into how are we really future-proofing you for the next 15 years? And that is really where we talked about the SPECT features I discussed already. And then on the CT side, I didn't even get to that yet. But we've updated and modernized the CT platform on our SPECT CTs. You have a minimum of 32 slices for each SPECT CT that we have. We have stellar detectors, tin filter, which allows low dose imaging on all patients. You have Sapphire, which is our reconstructive, one of our reconstruction algorithms that lowers dose but maintains and improves image quality. And IMAR. IMAR is our metal artifact reduction. Our metal artifact reduction is slightly different. You can apply it post-processing in 7 different algorithms to look at different types of metal implants. So you can apply, you need to apply IMAR before you start, just say that you're using IMAR, but you can select one type of metal implant. After, you can go back in and post-processing, reconstruct it again with a different algorithm for a different type of implant. So if you have a patient who has an area and may have multiple different types of implants in that area, you can reconstruct multiple times without having to worry about it. And you could do that automatically with just going into the workflow and asking it to recon again with a different metal recon. So like we talked about, that automated, reproducible workflow that's easy and intuitive, we get you there with the Symbia Pro.specta all the time. And what's really great about this is many of those are standard across the whole portfolio. Tin filter, stellar detectors, Sapphire, and IVR are standard across the whole platform. IMR is optional, but it was only featured on our prior generation's premium product. You couldn't get that on anything else. And tin filter is a whole new ball game. What tin filter does, it's an actual metal filter. It's a physical filter that hardens the beam and takes out radiation dose of the CT image of this from the CT. Anything that isn't giving any quality information to the radiologist, not helping you make any diagnosis or improve your image quality, we're filtering a lot of that energy out before it hits the patient, keeping the patient from getting increased radiation exposure. So we've been able to even lower patients' dose and continue to have great image quality.
So I believe for the Pro.specta, it's 32 and 64 are the slice options now.
Yes.
Does that
the minimum of 32?
Great. Okay, thank you. From just a diagnostic capability, how does that change things versus what you had before?
So in prior generation SPECT CTs, we went from 2 to 16 slices. It was CT technology that at the time it came out was still considered cutting edge. But CT grows really quick, and CT technology has changed really quick. And what we've done is updated to a new platform that starts at 32 slices and gives you better image quality than anything we could have produced before, with lower dose in many cases. We really are about future-proofing you. What we've done is gone to this new platform that will allow you to make sure that you have availability of this system for 10 to 15 years. As a radiology director, when you buy a SPECT or SPECT CT system, it is going to sit in your department. You're going to use it, and you're going to use it every day, and you're going to use it for as long as it works, and you need it to work for 10 to 15 years at minimum. What we've done is built on new technology that we can ensure that you will have parts availability for the next 10 to 15 years. We've gone from older CT technology, which, we've had a ton of supply chain issues lately. We wanted to make sure that we had newer technology with newer parts that were going to be available to you, all with adding those high-end features, including the tin filter, making sure you had imaging at low dose for your patients, lowering the dose from our previous generation, again, and giving your patients the highest quality image we can.
Great, thank you. And so I know we touched on Theranostics earlier, and I want to make sure that we come back to it because it's super interesting. So obviously it feels new. I don't know, how new is it, and how is Theranostics going to continue to evolve, or how do you expect it?
So Theranostics, in all honesty, is one of the first things that started nuclear medicine way back in the 1950s with iodine. We started with iodine for thyroid therapy. You had I-123, which you did imaging for, and you did therapy with I-131. It's a similar principle as we now move into the modern age of Theranostics. It kind of was kept small for a while, and now it's blowing up. You're starting to see a lot of new theranostic and diagnostic and therapeutic pairs coming to market. Off the top of my head, we're talking about neuroendocrine tumors, castration-resistant prostate cancer are the two big ones right now, but there are plenty more out there and coming. What we're seeing is many more in the European market than are available here in the US, so hopefully they'll be coming to our shores soon. And on top of that, we're seeing more of these therapeutic diagnostic pairs in clinical trials today than we've ever seen or heard of before. And that was one of the points with this system, is to make sure that you knew you were Theranostics ready, with the ability to image any kV from 35 to 588 kV. So you could get low, medium, or high energy isotopes on the SPECT side and image them as appropriate, with your diagnostics coming from the PET side now. So we really built this system to pair with what we know today is out there and give you the flexibility to work in the future with those medium and high energy isotopes that we're not even sure what's coming, but you have the ability with the broadest range of KV that is out there today. So you have that broad range to make you flexible for the future.
Wow, that's super interesting, and I mean, it feels like one of the more important things I've talked about on this show for a while.
We're super excited. It's really the personalization of medicine coming to nuclear medicine. We'll always have some of those types of scans that we've always done, the bone scans, the renal scans, the HIDA scans, that there's really no replacement for the physiological imaging that we do, which shows how well the body works. But what we're doing in the future is really seeing how well the therapies work in the body, which is amazing. And we're so excited to see how this comes to fruition down the road.
Thank you, Sebastian. And, kudos for all this hard work. It seems like you've probably coming off a busy couple of months, so it's good we have a long weekend coming up soon.
I look forward to it. It's been a busy couple of months, but I'm excited for where this is going to take us today, tomorrow, and down the road.
Right. Me too. That makes two of us. And so I would say thanks for coming in. For the audience, if you're on a nuclear medicine team or a molecular imaging team, and the idea of more efficient workflows for your patients or for yourselves makes sense, and higher image quality makes sense, and having a future-proofed and future-ready SPECT CT system makes a lot of sense to you for the next 15 years, talk to Sebastian and his team. Go check out the Symbia Pro.specta, and thanks for tuning in. And thanks for coming on.
Love to hear from you. Thank you. It was great talking to you, Jake.